In this class, we're going to go over past exam questions on general motion and uniformly accelerated motion. Okay, let's start with the first question. A train has an initial velocity of 44 meters per second and an acceleration of -4 meters per second squared. Its velocity after 10 seconds is A 2 meters per second, B 4 meters per second, C 8 meters per second, D 12 meters per second, E 16 meters per second. Okay? Now, let's start by writing out the information that were given in the question. We are given that the initial velocity of the train, solution. A train has an initial velocity of 44 meters per second. So the initial velocity of the train is equal to 44 meters per second. Okay? And an acceleration of -4 meters per second squared. The acceleration is -4 meters per second squared. Now, let me quickly ask you a question. Based on what we've learned in our previous class, what kind of acceleration is this? This acceleration is known as retardation. You understand? This acceleration that you see here is known as retardation. Retardation is the kind of acceleration that brings the motion of an object to rest. You understand? So A is negative, which means that we are talking about retardation here. Okay? So let's proceed. Now, you are asked to calculate the velocity after 5 seconds. So here, the velocity is what we are looking for. We don't know the value, and the value of time is what? 10. Okay? After 10 seconds. Okay? Now, don't forget, in our previous class, I gave you 3 equations of uniformly accelerated motion. Now, which of the equations are we going to use with respect to the parameter that we are given in this question? We are given the u, which is the initial velocity. We are given the a, which is the retardation, -4 meters per second squared, and t is equal to 10 seconds. Now we are looking for v. Here, we are going to make use of the first equation of motion. First equation of uniformly accelerated motion, which is v equals to u plus at. You understand? Okay? Now, how do I know that we are going to make use of this equation? The reason is because with respect to the parameter that was given and the parameter that I'm asked to calculate, this is the formula that is suitable. You understand? Okay? So let us substitute the parameter that we are given into this formula to get the value of v, which is the velocity that we are looking for. Okay? Here, v equals to u. U is what? U is 44 meters per second. So I'm going to have 44 meters per second. Okay, there is no need of putting units. 44 plus a. A is what? -4 meters per second. So I'm going to have -4 multiplied by t, which is 10. Okay, v equals to 44 plus -4 times 10, that is what? -40. You understand? So v equals to 44 minus 40. So here v equals to 4 meters per second. Okay, this is the velocity of the train after 10 seconds. You understand? Okay, so let's have another question. If a car starts from rest and moves with a uniform acceleration of 10 meters per second squared for 10 seconds, the distance it covers in the last 1 second of the motion is dash. Okay? We are given the following option: A 95 meter, B 100 meter, C 500 meter, D 905 meter, E 1000 meter. Okay? Now, okay, the options that is correct, please pay attention. Oh, I've switched it off. Okay, the correct option for the first question is that is option B. That is 4 meters per second. Okay, so let's proceed to the second question. We are told that the car starts from rest and moves with a uniform acceleration of 10 meters per second squared. Now, question 2 now. Okay, this is for question 1. Okay, question 2, solution. A car starts from rest. Okay. A car starts from rest and moves with a uniform acceleration of 10 meters per second squared. Now, pay attention to the first statement. A car starts from rest. that means that it is not moving at all before. That means that the velocity at that point is what? 0, you understand? All this we have learned in our previous class. So if you missed the previous class, kindly check the playlist on this channel, Uniformly Accelerated Motion. Watch those videos, you understand? By so doing, then come back, you'll be able to solve all these questions that you are solving, you understand? I take time to explain all these concepts, you understand? So when the car starts from rest, that means that the initial velocity is what? 0. So u equals to 0, you understand? And the acceleration that we are given in the question is what? 10 meters per second squared. So a equals to 10 meters per second squared. Now, for 10 seconds, so t equals to 10 seconds, okay? Now, what next are we given in the question? We are asked to find the distance covered in the last 1 second of its motion. The distance covered in the last 1 second. So, s in the last, let me just put it, last 1 second, okay? Now, the distance covered in the last 1 second is the difference between the distance in the 10th seconds and the 9th seconds. You understand? Please pay attention. The distance, you know that the time that you are given is 10 seconds. That is the time and the total time taken for the car to travel. You understand? Now, we are asked to calculate the distance covered in the last 1 second of its motion. That means that this distance that we are talking about is the difference between the difference of the distance between its 10 seconds and its 9 seconds. You understand? So, in an attempt to do this, which of the equation of motion are we going to use? We are going to make use of the second equation of motion, which is what? S equals to ut plus 1 over 2 at squared. S equals to ut plus 1 over 2 at squared. Now, this is the equation that we're going to use. Now, because we are told to calculate the, listen, we are told to calculate the distance that the car covered in the last 1 second. The equation will come like this. S equals to ut plus 1 over 2 a multiplied by t squared, t9 squared minus t10 squared. That is, please pay attention. I'm going to explain the reason why I put the equation like this. The reason is because the distance that we're looking for now is not the distance that is covered during the entire motion. You understand? It is the distance that is covered in the last 1 second of its motion. So that is why I have, oh sorry, this should be t10 minus t9. t10 minus t9. You understand? Okay? So that is the reason why I have t10 squared minus t9 squared. You understand? Okay? By 10 minus 9 is what? 1. You understand? That means that is the distance that is covered in the last 1 second will be the distance, the difference in the distance between the 10th seconds and the 9th seconds. You understand? So let's proceed. I'm going to have S equals to ut. So because u is 0, so t automatically will be 0, because when we take the product of t and 0, that will be what? 0. You understand? Even though we have a significant value of t, which is 10. 10 multiplied by 0 is what? 0. So here I'm going to have 1 over 2 multiplied by a. A is 10. All into brackets t10. That will be 10 squared minus, when t equals to 10, t will be 10 squared. When t equals to 9, that will be 9 squared. Okay? So here I'm going to have s equals to 1 over 2 multiplied by 10 multiplied by 10 squared minus 9 squared. That will be what? Okay, let's do it step by step. 10 squared is 100. This is what? 81. Okay? So here I'm going to have s equals to 1 over 2 multiplied by 10. Now, 100 minus 81, that will be 19. You understand? So here I'm going to have 19. So s equals to 1 over 2 multiplied by, now just take the division of 2 and 10. I'm going to have 5. You understand? So please pay attention, okay? Here I'm going to have 5. So I'm going to have 5 multiplied by 19. Okay? You understand? So s is equals to 95 meter. You understand? So the correct option for that question is option A. You understand? That is 95 meter. Okay? So let's proceed to another question. A body starts from rest and moves with uniform acceleration of 6 meters per second squared. What distance does it cover in the third second? Okay, that's question 3. Please pay attention. A body starts from rest and moves with uniformly acceleration of 6 meters per second squared. Since the body starts from rest, that means that u is equals to 0. So u is also equals to 0, and a equals to what? 6 meters per second squared. Now, let's proceed. Also, we are given that, please, what distance does it cover in the third second? The distance is covered in the third second. So, s in the third seconds. Okay, now if you look at this question, you will realize that this question is similar to the second question that we saw. You understand? Now we are still going to use the same step. Okay, we are still going to use the same step. Now, but this question we are not given the time. You understand? Listen to the, pay attention to the question again. A body starts from rest and moves with uniform acceleration of 6 meters per second squared. What distance does this cover in the third seconds? So we are not given a time, but notwithstanding, we can still determine the distance that it covers in the third seconds. All you have to do is that you are just going to plug in, we are going to use this same formula, you understand? So I'm going to have s equals to ut plus 1 over 2 at squared. So I'm going to have t3 squared minus t2 squared. Do you understand? Because I'm looking for the distance that is covered in the third seconds. That means that the distance that is covered in the third second will be the difference of the distance between the third and the second. You understand? That is the difference between the distance the car or the body covers when t equals to 3 and when t equals to 2. That difference in distance, that is the distance that is covered in the third seconds. Do you understand? Okay, so let's proceed. Here I'm going to have s equals to ut. Since u is 0, that means that t will be what? 0. You understand? So here I'm going to have 1 over 2 multiplied by a. A is 6, so I'm going to have 6 into bracket 3 squared minus 2 squared. Okay, so s equals to 1 over 2 multiplied by 6, that is 3. 3 multiplied by 3 squared is 9 minus 4. Okay, s equals to 3 multiplied by 5. Okay, s equals to 15. Okay, the correct option is option A. You understand? The correct option is option A, and this is a typical example of question that might come across in JAM. You understand? So the correct option is option A. Okay, so before we round up this class, kindly take this practice question. A body accelerates uniformly from rest at the rate of 3 meters per second squared for 8 seconds. Calculate the distance covered by the body during the acceleration. Okay, that is WAEC 1992. Okay, so take that as a practice question. In our next class, I'm going to provide the solution. Okay, to watch the next class, you can check the description of this video. You're going to see some link there. Click on those links to watch other classes. You understand? Okay, so see you in the next class.